Good evening, students. This video is regarding practical 6 content of ECE 216. So if you look at your lab manuals, practical 6 deals with the designing of a counter, and the counter that we are designing in this particular practical is a synchronous one. That means the clock pulse would be given to all the counters at a time. And since we are designing it for a 3-bit, it means the number of states would be given as 8 only. As you very well know, for n number of bits, if we are having n number of bits, then the total number of states a counter can have is equal to 2 to the power n. So if n value is equal to 3, so we can say number of states is equal to 8. And since we have to create two different types of counters, one is for up counter and one is for the down counter, so the sequence that is coming at the output would be different. If it is up counter, the counting would be from 0, 1, 2, 3, 4, 5, 6, 7 in binary. And similarly, if suppose we are designing a down counter, then your sequence would start from suppose 7, then 6, then 5, 4, 3, 2, 1, 0. So this is what we are looking at. Now if we see the diagram of synchronous up counter from our lab manuals, this is the diagram being provided. Now if your question is regarding how this diagram is coming, that is the part of ECE 213 theory. We'll be designing this counter again there. So I would be telling you all the details, like how this diagram is basically coming from. But as per the practical point of view, the important things to note down is we are using here a JK flip-flop. So if we are doing this practical, we need an IC regarding this, and the IC that is available is 7476. So 7476 is the IC which we will be requiring for this practical. And plus you can see here there's a AND gate also. So for this AND gate we require 7408. So for this practical, two things that are important are the IC 7476, and now this 7476 is a dual master slave JK flip-flop. So one IC contains two JK flip-flops. So if we see our diagram, it contains how many you can say flip-flops? 1, 2 and 3. So there are 3 JK flip-flops here, and one IC contains only 2 JK flops. So we need 2 ICs. Is this clear? We need 2 ICs of JK flip-flop because one IC contains only 2 JK flip-flops, and additionally we need one AND gate to cover this circuit. Now give you a brief description regarding IC 7476. So as I said already, it is a dual JK flip-flop, and you had also remember it is a master slave configuration. So once you will be doing this on practicals, you will not be finding any unstable state, or you can see you cannot see any race around condition happening over here. And if we have to study the pins of this flip-flop, then you can see in this particular diagram there are 2 JK flip-flops inside this IC. Then pin number 5 is VCC, means there is a voltage given here. Pin number 13 is ground. Then if we see here, clock pulse is given to this flip-flop, and similarly if you are using this set of JK flip-flop, then your clock is given here. So you can see there are these subscripts given 1 and 2. So 1 refers to first JK flip-flop and 2 refers to the second JK flip-flop. So clock is here. Then the inputs are J and K. So you can see the pins here, 1J and 1K. So the inputs of J and K are given from here, and we know the outputs are Q, Q bar. so we are having 2 pins allocated to them also, and same is applicable for set number 2, means the second JK flip-flop. There is the input J, there is input K, then similarly there are 2 outputs Q bar. Now the pins that are left are these 2, okay, and this is for both the sets. So PR, it stands for preset, and CLR stands for clear, and same is applicable here also. So preset is like if there is any output coming at Q and you want to directly have output as 1, so you can press preset button, and clear is for clearing the output. So if you want at output directly 0 output, so you can press clear button. So clear button makes your output as 0, and if you are pressing preset button, then your output would be directly 1. So while we are doing this practical, we do not need these inputs, you can say. So you had to disable them. So what we need in this practical is the pin number 2, 3, 7 and 8. We need to disable them all, so that we can continue with our circuit operation where the counting is going either from 0 to 7 or from 7 to 0, depending upon whether your counter is up counter or down counter. So after we understand how basically this IC is going to work, now you can try by basically here the connections. So this is your 3-bit synchronous binary up counter diagram. As I already told you how this diagram is designed, it is a part of AC213 theory, where we will be covering this topic again. So till then you can try for connections, and let us understand the connections first. So as we know, it has to work as a counter, so it must be in the toggle mode. So the toggle mode condition we very well know is your inputs J and K must be 1. Then you can see here the inputs J and K for all the flip-flops are connected together. J and K are connected together, and it is connected to high. High means VCC, that is 1. Similarly, you can see here J and K is connected together. Similarly, here J and K is connected together. Okay. Now if we want to design this IC on the IC, so you can see there are 3 JK flip-flops being required. So this is the first JK flip-flop I will be using, suppose this is the second one, this is the third one. So I need 2 ICs basically. So you can try making connections as we have been doing in the past practicals. Suppose J and K are to be short circuited. So what you can do is, this is the J, this is the K. We can short circuit these two and we can connect it to VCC. So we have to follow the diagram only. The Q is the output of this flip-flop, and that is going as input to J and K of the second stage. So the Q, that is the output of the first flip-flop, is going as input to J and K of the other flip-flop. So if I consider this as first flip-flop, this as the second one, so it's J and K, you have to short circuit first of all, and then it is connected to Q. Similarly, if we look at this AND gate, the 2 inputs to this AND gate, now I will represent here AND gate like this only, but you know, if it is practical, then you have to replace it with IC 7408. This is 7408. So what are the 2 inputs that I should give? The first input is coming from Q0 and the second input is coming from Q1. Means 2 outputs of 2 JK flip-flops that you have used, they will be acting as inputs for JK. So you can see the 2 outputs here. First output is 1Q, so 1Q is going as input, and similarly the second Q, that is here, it is acting as input. And then you can see the output of this AND gate is acting as an input, and the JK are again shorted. So since I have used both of them, so I need the second IC, and this is my third JK flip-flop. So J and K, so this is my J, this is my K. Again you need to connect them together, and then this output is going here. Then we are left with the clock. You can see this clock is given simultaneously to all three flip-flops. So this is a synchronous design. Now we have to repeat it here also. So let us find out where is clock. This is clock for first JK flip-flop, this is clock for the second, this is clock for the third. So you have to connect all of them, and you will connect here clock. This clock is coming from the digital trainer kit, and you will set it at 1 Hertz. Then what about the output? The output that you are observing, that output is basically coming at Q. So the LEDs would be connected wherever Q is present. So these are the three LEDs where basically you will get a sequence like 0 0 0 0 0 1 0 1 0 and so on. So let us see here the outputs. Now this one Q, this is the first Q, so here there will be an LED. Similarly here, this is the output, it will be you connect it to LED. Similarly this output. Okay, so wherever the Q is available for the flip-flop, that Q you have to connect with LED where you can check the outputs. So we are having, you can see, three LEDs, and these three LEDs you will see once you will start the counter, it will start counting from 0 0 0, then 0 0 1, actually in this sequence. Basically what you have to remember is this will act as MSB because we are giving clock from this side, and this is LSB. So the sequence you would observe will be in this fashion only. So this is 0, this is 1, then 2, 3 will be followed by 4, then 5, then 6, and then 7. So this is the sequence we would be observing. But still the connections are not actually complete. As I said here, your pin number 2, 3, 7 and 8, it has to be disabled. So we can again come back over here. Actually what I said is your reset pins and your, you can say, preset pins, they are to be disabled because we want the normal operation to happen. So what are we going to do is this preset, this set, then again this preset and clear, again this preset and clear. We will connect it all, to VCC, that is logic 1. So what this will do is it will disable your clear and the preset, and your counter will start normally operating from 0 to 7. And the same thing you can see while you are designing it for down counter, suppose, where the sequence would be opposite in this fashion. It would start from suppose 7, then 6, 5, 4, 3, 2, 1, 0. And if we compare the diagrams, this is a diagram for the down counter. If we compare two diagrams, the diagram is very much similar, except that the points to be noted are, if we see here J and K, it is connected to Q, and if we see here J and K, it is connected to Q bar. Similarly here you see again your J and K, it is connected to AND gate, but inputs were coming from Q. If we see here, it is again connected to AND gate, your J and K, but previously the inputs of this AND gate were connected from Q and Q, Q from the first stage, Q from the second stage. But if we see this AND gate, the inputs are coming from Q bar. This is Q bar of 0, this is Q1 bar. So why I am trying to highlight this is because once you have designed this circuit, on breadboard, or you can say on the digital trainer kit, there are only 2 or 3 connections that you need to interchange. You don't have to remove all connections. you don't need to remove all the connections. Why? Because all the connections remain same. Your set, your reset, it all remains same. The input J and K, you can see here is 1, here also it is 1. Your clock also remains same. So you have to just identify the main you can say changes that are happening over here. So the changes are, instead of this J and K being connected to Q, it is connected to Q bar. So here it was Q, here it is Q bar that is propagating from one stage to other. So identify these two or three three connections that are getting changed. So replace these connections, so you can convert basically your up counter into a down counter. So if like this is an exercise for you, like I have done it over here, all the connections. So you can try to have all the connections for a binary down counter over here. So very quickly I will tell you the procedure how to do it. So we need two ICs of 7476 to do this practical, and plus you need one IC of AND gate over here. You need one more IC, that is 7408, to perform this AND operation. Then, as I said, important point, your set and reset pins must be connected to VCC so that we can disable your set and reset, and your counter will start normally. And we also had to ensure that the LEDs where you can observe your output is connected, the LEDs are connected at the output pins of Q, and then you will just observe how things work as per the connections you are making. And you can revise this practical, and if time permits me, I will also do the Proteus simulation of this particular experiment, so that you will get the practical learning regarding this practical. Any doubts you are having, you can ask me, and so please go through it, and I hope this video was helpful to you. Any feedback coming from you is always welcome. So God bless you all.